All right, first session up, the lamb to the slaughter. Samuel Just. We're going to talk about the OSD scrub and repair. You want to give us an overview of your blueprint and go nuts?
Can you guys hear me?
Yep.
Sorry, to pull up the stupid blueprint.
Go nuts.
Okay, so if this looks familiar, it's because it is. This is the same as we talked about in the GH session, one CDS ago. The basic problem is that Scrub currently is both conservative and not particularly clever. So if you have 3 replicas and one of them becomes, if you have 2 replicas, one of them becomes corrupted, then clearly the OSDs cannot infer much about that. So it, I think, takes the lowest numbered OSD as the correct replica at the moment and just goes with it. I believe the same is actually true for 3 replicas, even if 2 of them agree. So we can add some intelligence, like with 3 replicas, we can have them vote. But in general, we'd like to get to a place where the Rados interface can actually output useful information about the nature of the inconsistencies. So that something like Calamari or some other tool can present this to the user in a way that is intuitive and helpful, and that the user can use to direct stuff as to how it wants the problem resolved. So to that end, there is a brief start of a concept for how we might work this into the existing interface. The challenge implementation-wise, of course, is that this thing where we know what OSD is the object on is exactly the kind of thing we usually don't tell people for the Rados interface. So we have to sort of think carefully about how we want to work with that, and how we want to work with the fact that the interval might change, that the acting set for a particular object might change during this process. So I think we started hashing this stuff out last time.
I seem to recall we had a discussion about... Who's echoing? Is that you, Sam?
Almost certainly. Sorry, let me put on headphones.
Okay. I seem to remember we had a discussion about whether we should put this in the Librados interface, so we'd actually define these sort of structured C calls to query this stuff, or whether we should use sort of the sideband management stuff and have JSON queries and responses.
Oh, yeah. Wait, can you guys hear me now?
Yeah, that's much better.
Cool, okay. I do remember that discussion. You seem to argue that it would be a lot simpler that way.
For the JSON.
Yeah, I seem to argue that this needs to become that those interfaces usually are usually kind of impermanent, and we really want this to be well, I mean, actually, so exposing it through Librados doesn't necessarily mean that it doesn't go through the command interface, because we now have things in Librados that go through the command interface, right? That's how Calamari works.
Yeah, exactly.
We could do it that way.
It would be like so there's a PG command basically that already exists in Librados that you can just have a JSON blob that goes in and a JSON blob that comes out, or whatever you want actually, but I think we would use JSON.
Predates Calamari, by the way. That was there for the Ceph library, right?
Yeah, right.
Exactly.
Okay, so that would an existing tool would be able to use all this, and we wouldn't have to do any additional client-side coding, at least, to use these interfaces.
Yeah, that could work. The same basic things need to be there, though. It'll just, instead of being this, it'll be JSON, whatever.
Okay. So you would list...
Oh, go ahead.
So you'd have something that would query which PGs are in the inconsistent state. That would be a monitor command. And then for any given PG, you would query that individual PG and you'd ask for lists of objects. Okay.
Add an epoch so you know when you need to start over, that kind of thing.
Mm-hmm. Yep. Okay.
I mean, there are a couple of sort of larger philosophical questions about this. For example, we don't usually handle EIO on read particularly well, so it might be that it's even more important to do that first. But yeah, this is how I think the scrub and repair need to work.
So Guang actually had a pull request comment yesterday or this morning about that, actually. Trying to make the conservative first step being to make an EIO on read equivalent to what would happen if a scrub got an EIO, where it would mark the PG inconsistent. And then probably work around that individual read just by reading from a replica, doing like a proxied read.
Did he actually do that, or is that his comment on what he'd like to do?
It might have been my comment actually on what I think he thought he should do. I think it was his comment.
Well, I mean,
but yeah, that was
the hard part is the proxied read, right?
Yeah.
So that's the machinery we need to add.
Yeah. We have an object instance now, so it's probably not so bad as it's probably not so bad.
I mean, you could do it that way. Would we do it that way? Not sure.
I think probably. I mean, we could send a redirect to the client and have them read from the replica, but then I don't know. Then it's all.
I'd almost rather just block the op and scrub that object and then repair that object.
Yeah, the only reason I would shy away from that is because scrub right now doesn't do that. We wait for the administrator to do scrub, and so I don't know that we'd want to do it on read either.
I guess that makes sense.
We're going to have the same behavior.
Well, for erasure coded objects, this is actually kind of trivial.
Yeah.
Oh, I remember why this is hard. Because we can't. We require synchronous reads in replicated PGs. This is easy for erasure coded PGs, but lots of things require you to do the read and have the information right there done because of object classes.
I see.
Erasure coded PGs don't allow you to do that, so all you have to do is mark the object as missing on that OSD and then do the rest of the read path.
Got it. Okay. But but we need to do those async reads on replicated PGs anyway in order to, for example, get object class support for erasure pools.
Right. So, well, I don't know if we want to.
Assuming that matters, but
it kind of matters because literally the only reason we don't do it right now is that object classes are you get a single call and that's it. If you were allowed to chain callbacks, then it would be done and it would be a more powerful interface for it.
I guess that's actually the opposite thing though, because that would be. Yeah, so we need to add the async read handling to the replicated PG.
Actually, I think.
Is that what you're saying?
Well, we need to change the interface so that all of the things that there are a number of things that don't work in erasure coded PGs because they don't have synchronous reads. So those things have to no longer be a problem for us to use asynchronous reads in replicated PGs.
Okay. So making
and it's pretty much object classes.
Yeah. Okay. So making async reads work in replicated PG means that all the things will then work with async behavior. And then
making all of the stuff that currently requires synchronous reads okay with async reads means that we can pretty much do away with synchronous reads.
Right. Yep. Which is probably good anyway, because it's kind of stupid that we're doing all read synchronous. They tend to block. Okay.
Oh, that's a thing we might consider. Sorry, tangent. The object store interface we're talking about transitioning to might be asynchronous read-based.
The object store interface.
So the actual calls into the object store that do reads are all synchronous right now. We might consider making those async.
Yeah. Okay.
Or some kind of hybrid thing.
Or some hybrid, where it could do either or something.
Yeah, because we do want the option to avoid the context switch, but
yeah. Yeah, we probably want to make the read like conditionally either return
the result or a tag or something.
Yeah. Yep. Okay. That makes sense. Yeah, because for the fast backends, we definitely don't want async on writes even.
Probably. Maybe.
Depending on how fast.
Because you have that sequencer. Well, you have that sequencer thing going on and some kind of consistency. Yeah, that's maybe.
All right. Okay, so anyway, the pieces here are listing the PGs, listing the inconsistent objects within a PG, and then repairing it in a particular way. See, the other thing The other thing about having JSON here is that like the replica to use wouldn't be an integer, but it could be like a vector of which shards in the EC pool to repair from, for example, if you knew that certain ones are valid or something.
Oh, that's true.
So it just makes it easier to have some flexibility.
Generalize. Yeah.
Um,
Although, actually, I would argue that the JSON schema is pretty much exactly as constricting as a C++ interface. I'm not sure there's a real difference there.
yeah, I guess.
Actually, with erasure coding, does this ever come into play? Because we always know whether an erasure coded shard is correct.
I mean, if we assume that the checksum is perfect, then yes.
Oh, I mean, well, hang on,
And
no, because you can't compare them without the checksum anyway.
it might even be that you say that the checksum is wrong and you want to try to repair it, and you'll get some like garbling, like say you had a bit flip.
Yeah, but it still won't match the checksum. We don't.
Right.
Let me put it this way: when we recover it back, those checksums are a priori. They're not calculated. As you append to the object using the original client data, we update a vector of checksums in the xedder. We don't ever regenerate that from the shards themselves. It's always based on the original writes.
Yep. Right, but say you had a bit flip in the data, and so you had a bunch of shards that were corrupted, but you wanted to try to reconstruct the data anyway.
There'd be no way to. You'd have to overwrite the object. Anyway, right?
Yeah.
Either you have enough valid shards to reconstruct or you don't.
Right. Yeah.
I guess I'm missing it.
Well, maybe you would rather have a garbled reconstruction than no reconstruction at all.
Oh, I guess that makes sense. I would argue that that's better accomplished by having an option to delete the object.
If you can do that reconstruction offline.
Oh no, I mean
Maybe.
yeah, but
yeah.
A truly garbled object, I mean, is that ever more valuable than nothing?
Possibly.
I guess it could be more valuable than nothing. Maybe it's like a 10 megabyte object, and you happen to know that the corruption
it's
is
only exactly
localized.
Right. It's only one strike.
Okay, that's a fair point.
Yeah. Anyway, I think that the important bit here is that you'd be storing the results of the scrub in the per VG scratch object, which is cleared during peering reset. During every peering reset?
Let me think. I thought.
Or just during like a primary?
Yes, because it's not a real first class Rados object. It's just persisted primary state because we don't want to keep it in memory. But that's the only thing it is. It's just so that we don't have to keep it in memory.
Okay. Okay.
It occurred to me that a truly garbled PG might have enough crap in it that we literally can't afford to keep that in memory. So we want to offload it to level DB.
Yeah. Yep. Definitely. All right. So the piece that's might be missing here though is that in deciding which replica you want to use to repair, then you want to be able to fetch that particular replica or shard.
Oh yeah, that's Oh, I didn't. Yeah, we got to that last time, and you're correct. That's a good thing.
Would that also be? That might not be as good a fit for the sideband. I guess no. You can pass arbitrary byte. So it's a regular. It's an actual buffer payload that comes back, and so you could actually pass the actual.
So that's true, but commands don't go through all that stuff that does ordering.
Yeah. Okay. So
still, there's no reason actually that piece has to go through the same place this stuff does. It's pretty much just a way of expanding the. Hang on, you can only repair. Yeah, you can only repair from an OSD in the acting set anyway. So it's a way of expanding the read from local replica thing to allow you to specify the replica.
Yeah.
Which is fine. Yeah. I don't have a problem with that.
And on reading individual shards, would be because that's actually not even the data. You want to get the raw. Or I don't know if we would we want to do that? Seems like for completeness we would want to allow you to do that.
Yeah, I mean, no particular reason not to.
except that it's a new thing to do. It's different.
Well, I'm wondering if it turns out to be we just don't check this path. But
Yeah.
no, I think you're right. I think it's reads are too different between erasure coded PGs and replicated PGs.
Mm-hmm. Yeah, I mean, I think we would want it. We would want a client to be able to read the shards that have the unencoded data anyway, because eventually we might want to have the client optimistically try to read pieces directly from the OSDs that they come from, and only if they like miss the versions mismatch do they fall back to going to the primary and doing a sort of a synchronous orchestrated read, just to optimize that I/O path. So it'd be the same there, except for the shards that aren't actually part of the. They aren't actually the data shards, but maybe it's the same. Maybe it'd actually be the same thing.
Well, I don't like the OSDs actually don't know which ones are the data shards, or they do, but they defer that to the EC plugin. It's not their problem.
That's true. I guess it just have to be it would have to be a separate read that reads the raw shard and not the
exactly
semantic result or whatever.
I think I guess we'll want that anyway.
Yeah.
Yeah, it has to return like a shard and some other additional metadata anyway, and I don't think it makes sense to bury that any further than the Liberatus interface anyway. We might as well bubble that all the way up.
Yeah, exactly. But there's already that like sort of locator scheme that we're using to indicate whether we want to read from a replica or not, or what the locator is, the key, whatever you call it, when you're reading from an object.
That seems like
it's a property. It's hidden state on the I/O context that you can set before you do a read that says that this object is stored in a different PG slot or whatever. There are a couple
well, yeah, but exactly one layer down, it's then just a different object you're querying.
Yeah, right.
Right.
But that could be, it could bubble up in the same way, I guess, without having to redefine a read and a write or a read. It takes extra arguments. Yeah, I guess that doesn't matter too much.
I think it's just an extra I/O context method that is read raw replica OSD object name with the usual object locator stuff. That stuff all works the same way.
Or a rank. Yeah.
Well, I think you need a way to query the. We want it to go by rank or by OSD?
I think for the shards we would want to go by rank. Read, because you might have both shards on one OSD even.
I know. I'm thinking though that we might want it to be a tuple of OSD and shard, because if we're using the repair thing, we actually don't want to accidentally read after a peering reset from the wrong shard. We really do care about which OSD it is. Like it's the OSD shard combo that we actually care about.
Yeah. Okay.
Maybe you don't leave. Maybe there are two versions. One where you're allowed to specify the OSD and the shard, but you also have to specify the epoch you got back from whatever method you used to find out what shard it was in, and you get back an E again if it's stale, which the objector can do locally.
Yeah.
Right.
Okay.
And the other one you just specify the shard, and that works all the time.
Yeah.
You make an E. Well, no, I guess you get an E again if that slot in the acting set is empty at the moment.
Okay. Would we go as far then as making a tool that would help you examine those? So then that means the Rados CLI tool probably needs an option to get like replica 0 or 1 or whatever.
Yeah, I think that's the test case. Yeah. And then a calamari screen and then the world.
And we might want to wire up a Rados like check object or something that will query the scrub state for an object.
Yeah.
Instead of using this, maybe. So this is a kind of a tangent, but when I was at that the archival storage thing last month, one of the things that repeatedly came up is the ability to have a challenge that you can send to your storage system that says, prove to me that you actually have this data and that it actually is still accurate and up to date and all that. And in the archival context, the way you do that is you basically, before you store it, you hash it with different salts. And so you sort of know what the hash should be with a given salt. And then you ask the storage system later to do it with one of those salts that you've never told it before. And the only way it can give you back the right hash is by actually, if it had a copy of the data and can confirm that it's there. That's sort of different here, but I'm still thinking that there's there should be something that says, make sure you have it, I guess. So query whatever the current. I guess all we're doing here is we're just making sure that Scrub hasn't already detected an error. We could make something that actually explicitly scrubs one object, though.
Yeah, see, Scrub feels like it has all the requirements of a read. Like, you can't be doing a write at the same time, and that's it.
Yeah.
Like, for a single object, it seems like we can convert the whole thing where you scrub an object into
a read.
A read.
Yeah.
The only reason not to do that in the general case is that we don't want to scrub one object at a time.
Right. Like a per object scrub. I think somebody actually brought this up too, where there's this potential where you have 3 replicas, say, and one of them gets a bit flip, and it happens to be the primary, and you won't notice for 2 weeks until you do your scrub.
Yes.
And meanwhile, you can be reading from it, and you won't notice. And so having an option that on read will actually read from all replicas and make sure it gets the same answer before it returns the result to the client. That's basically the same thing.
Also requires async reads, though.
Yeah. Yep.
Boy, sync reads are a real bummer.
But they're a bummer for other reasons too. So.
No, I mean it's just like blocks a lot of things you might want to do on read.
Yeah. Well, all the locking that is in place is fine, right? Like we don't have to change the locking schemes. It's really just making a completion for read. Yeah, because it's the same code for the erasure code PGs. It's really just that.
Yeah, it's just that object classes have to be adapted so that they can deal with an asynchronous read.
Yeah. Yeah. Yeah, okay. That probably means that the object class itself has to tolerate an E again back from the method and then return E again, right?
I don't think so. I think we changed the whole object class interface, actually. I think old style object classes still require synchronous reads, and we rewrite all of the object class methods so that you provide a completion. It's just more elegant that way.
Yeah. It makes it hard to code when you have lots of, like, you're getting attributes and statting, and
that is a classic problem that is indeed annoying, but
in C++.
well, people have and continue to solve that problem on a regular basis.
Yeah. Yep. Okay.
All right, we're running up to the end of our session time here. People have questions they want to ask.
But what's the priority here is, as far as just the task goes, probably the first thing to do is store the grub result state, right? And then add query methods to whatever the admin interface. And we would want to.
Oh, okay, yeah. So maybe scrub shouldn't be a read, but repair should definitely be a write, because we need to be able to do this on a per object basis and have it be like reasonably
which is
normal.
what it is that actually anyway, right? We create a rep op on repair, so okay.
Wait, no, we don't. We mark the object inconsistent or missing and then run recovery.
Oh yeah, you're right. Well,
we may do that under the covers, but we need to be able to do it through a Rados operation, I think.
Yep. Okay. So the ability to breed from any replica for shard. That goes into Liberatus. And then okay. And then async reads, and then right. All right, cool. Cool.
Does that pretty much wrap that one up, does it?
Mhm.
All right, I'm not seeing any questions coming in, so I think we're good.